Welcome guys. Today I'm gonna be tackling the day 12. It's the web timing attacks day. Yeah, if I can't steal their money, I'll steal their joy. Okay, let's dive right into this. Okay, so Warville's bank had a huge turnover this year and expected a massive profit before the holiday season. They were eager to disclose this news to the townspeople during the Sockmas celebrations. However, to their surprise, things went the other way around. After completing the annual calculations, the accountants were shocked to see a considerable loss. They observed discrepancies in the account balances. The bank called Max Kitty to help investigate these users' fraudulent transactions. Upon analyzing the bank's website's transactional logs, Max Kitty found some interesting transactions. Few users, including the mayor's team, initiated multiple transactions from Werebill's reserve accounts at once. Surprisingly, all these transactions succeeded despite exceeding the user's current balance. Glitch was already aware of the critical vulnerability, allowing these fraudulent transactions that Mayor, malware, and its alliances exploited. So the learning objectives here are understand the concept of race condition vulnerabilities, identify the gaps introduced by HTTP2, exploit race conditions in a controlled environment, and then learn how to fix the race. Okay? Connecting to the machine, let's start this box already. I'm not giving any credentials, but I'm gonna be using the attack box, which means my Kali box, right? Okay, Bank's application is in the 5000 port. Okay. Uh, Please wait 1 to 2 minutes after the system boots completely to let the auto scripts run successfully. Okay, so web timing and race conditions. Conventional web applications are relatively easy to understand. Identify and exploit. If there is an issue in the code of the web application, we can force the web application to perform an unintended action by sending specific inputs. These are easy to understand because there is usually a direct relationship between the input and output. We get bad output when we send bad data, indicating a vulnerability. But what if we can't find vulnerabilities using only good data? What if it isn't about the data but how we sent it? This is where web timing and race condition attacks come into play. Let's dive into this crazy world and often hidden attack surface. So, in its simplest form, a web timing attack means we glean information from a web application by reviewing how long it takes to process a request. By making tiny changes in what we send or how we send it and observing the response time, we can access information we are not authorized to have. Race conditions are a subset of web timing attacks that are even more special. With a race condition attack, we are what? Um, yeah, here, with a race condition attack, we are no longer simply looking to gain access to information, but can cause a web application to perform unintended actions on our behalf. So web timing vulnerabilities can be incredibly subtle. Based on the following research, response time differences ranging from 1300 milliseconds to 5 nanoseconds have been used to stage attacks. Because of their subtle nature, they can also be hard to detect and often require a wide range of testing techniques. However, with the increasing adoption of HTTP2, they have become a bit easier to find and exploit. Listen to whispers, web timing attacks that actually work. Okay, this is the article. Um, Websites are riddled with timing oracles eager to divulge their innermost secrets. It's time we start listening to them. Okay, I'm gonna read this afterwards. It's a long post. So hopefully this teaches me about that, about this particular research, right? The web timing vulnerabilities. Okay, continuing on. So the rise of HTTP2, right? HTTP2 was created as a major update for HTTP, the protocol used for web applications. While most web applications still use HTTP 1.1, there has been a steady increase in the adoption of HTTP2 as it is faster, better for web performance, and has several features that elevate the limitations of HTTP 1.1. However, if implemented incorrectly, some of these new features can be exploited by threat actors using new techniques. Okay, so a key difference in web timing attacks between HTTP 1.1 and HTTP 2 is that HTTP 2 supports a feature called single packet multi-requests, right? Network latency, the amount of time it takes for the request to reach the web server, uh, made it difficult to identify web timing issues, right? So it was hard to know whether the time difference was due to a web timing vulnerability or simply a network latency difference. However, with single packet multi-requests, we can stack multiple requests in the same TCP packet, eliminating network latency from the equation, meaning meaning time differences can be attributed to different processing times for the requests. This is explained more in the animation below. Okay, so there's an HTTP. In HTTP 1.1, you make a request to the web server, and then you get back in a particular time. You get a response back in a particular time, right? In milliseconds. But when it's HTTP 2, okay, you communicate with them, and then you get a response with 33 milliseconds, okay? 30 to 33, okay, the time difference, internal latency minus X. Considering that both time difference is 3 milliseconds. Okay, yeah, I see you. Okay, so HTTP 1.1 takes like 30 milliseconds, right? While HTTP 2.2 is the one that takes 33, right? A difference of 3 milliseconds, right? So with network latency a thing of the past, only server latency remains, making it significantly easier to detect timing issues and exploit them to recover sensitive information. Okay, so typical timing attacks. Timing attacks can often be divided into two main categories: information disclosures and race conditions. So for the first one, leveraging the differences in response delays, a threat actor can uncover information they should not have access to. For example, timing differences can be used to enumerate the usernames of an application, making it easier to stage a password guessing attack and gain access to accounts. And then the race conditions. Race conditions are similar to business logic flaws in that a threat actor can cause the application to perform unintended actions. However, the issue's root cause is how the web application processes requests, making it possible to cause a race condition. For example, if we send the same coupon request several times simultaneously, it might be possible to apply it more than once. For the rest of this task, we will focus on race conditions. We will take a look at the time of check to time of use, TOU, okay, flow. Let's use an example to explain this as shown in the animation below. Okay, there's a request from the computer, the time it takes, the request number one, submit discount code, code already used, false, apply discount. Okay, so you make a request, then what time? This is another one, two requests, and you get a response. What did I do? Oh yeah, here. So it got already used, true. Damn, I don't like this, because I'm not able to control this animation. I wish it was. So when the user submits their coupon code in the actual code of the web application, at some point we perform a check, right? That the coupon is valid and hasn't been used before. Yeah, makes sense. We apply the discount and only then do we update the coupon code to indicate that it has already been used, right? In this example, between our check if the coupon is valid and our update of the coupon being used, there are a couple of milliseconds where we apply the coupon. While this might seem small, if a threat actor can send two requests so close together in time, it might happen that before the coupon is updated in request number one, it has already been checked in request number two, meaning that both requests will apply the coupon. Oh, I see. So winning the race. Now that you understand basic concepts related to race conditions, let's explore how this vulnerability occurs in a real-world scenario. For this, we will take the example of the Warevilles banking application hosted in this particular um, IP, right, with a port 5000. Okay, so this is the banking application. It asks me for some login information, which I don't have. This application allows users to log in and transfer funds between accounts. Okay, so intercepting the request. Before we start intercepting requests, we need to configure the environment so that as a pen tester, all web traffic from our browser is routed through Burp Suite. This allows us to see and manipulate the request as we browse. We'll use Burp Suite, a powerful, okay, here, Burp, start this already. A powerful web vulnerability scanner to intercept and modify requests for this exploitation. You can access Burp Suite in the attack box. On the desktop of the attack box, you will see a Burp Suite icon as shown below. Yeah, sure. Start Burp. Once you click the icon, will open with an introductory screen. Welcome to Burp Suite. Click next. Yeah, I already know how to handle this, so I will just be reading through this very quickly. Yeah, has started. Yeah, okay. So we have this. I normally like to operate for this whenever I'm using Burp Suite to intercept requests. I just like to use their own particular browser and access this. Okay. So now, yeah, we have that. What is it that you're asking me to do here? Once Burp Suite has started, you will see its main interface with different tabs such as proxy, trigger, repeater, and others. Inside Burp Suite, click the settings tab at the top right. Settings tab here, and then what you want me to do. At the right, you will see Burp's browser options available under the tools. Allow Burp's browser to run without a sandbox option. Where's that? Under the tools, yeah, we're here, under the tools. Allow Burp Suite. Okay, at the right you will see Burp's browser options available under tools. Allow Burp's browser to run without a sandbox option. I'm just scanning through this real quick. Where's that? Burp's browser. Okay. Here, allow to run without a sandbox. Okay. So you want me to enable this? Okay. And click on the close icon on the top right corner of the settings. Okay. Already did that. Tab as shown below, right? So we enable that. And now after allowing the browser to run without a sandbox, we would now be able to start the browser with pre-configured Burp Suite's proxy. Open the browser by clicking the Open Browser located in the Proxy Intercept tab and browse to this particular so all requests are intercepted. The intercept is off though, right? Once you browse the URL, all the requests are intercepted and can be seen under the proxy HTTP history, right? Yes, we can see that. Tab, right? Application scanning. So as a penetration tester, one key step in identifying race conditions is to validate functions involving multiple transactions or operations that interact with shared resources, such as transferring funds between accounts, reading and writing to a database, updating balances inconsistently, etc. For this example, we will log into the Warebills banking application using the credentials 110 and tester. Once logged in, you will see the following dashboard. Okay, let's log in. Tester. Oh, I think I mistyped it. No, I did not. Yes, I mistyped it. Anyhow, I'm allowed access. Never. Okay. Once logged in, you will see the following dashboard that will contain the following two primary functions, right? Transfer money. Welcome tester. Transfer money. Amount to transfer. Okay. So you will see two functionalities. Log out. Yeah, log out. This is the button here in red, which probably does not involve simultaneous tasks. The next is fund transfer, which might do, right? Which includes deducting funds from the account and adding them to the other account. As a pen tester, this could be an opportunity for an attack. We will see in detail how, as a pen tester, you can exploit this vulnerability. So verifying the fund transfer functionality. We'll browse the bank application and perform a sample transaction inside the browser. This will generate multiple get and post requests, and whatever requests we make will be passed through the Burp Suite. As shown in the figure, our current balance is $1,000. So we will send $500 to another bank account with the account number. Okay, so let's send 500 to the account with, oh no, 111, and here it goes, the amount, right? And while doing that, all our requests will be captured in the Burp Suite. So click on the transfer button and you will see the following message indicating that the amount has been transferred. Okay. Yes, success transaction this. Yeah. Now let's review the fund transfer HTTP post. This is the transfer. A request logged into Burp Suite's HTTP history option under the proxy tab. Yeah, we can see that. So the account number is 111 500. Yeah. Then what else do you want me to see here? So the above figure shows the transfer endpoint accepts a post request with parameters account number and amount. The Burp Suite tool has a feature known as Repeater that allows you to send multiple HTTP requests. We will use this feature to duplicate our HTTP post request and send it multiple times to exploit the race condition vulnerability. Right-click on the post request and click on Send to Repeater. Okay, Send to Repeater. Now we go to Repeater. Now navigate to the Repeater tab where you will find a post request that needs to be triggered multiple times. We can change the account number from 111 and the amount value from 500 to any other value in the request as well, as shown below. but you didn't change anything here though. So please place the mouse cursor inside the request, inside the repeater tapping verb suite, and press Ctrl R. To duplicate the tab, press Ctrl R 10 times to have 10 duplicate requests ready for testing. Okay. Place them inside the request, inside the repeater, Ctrl R, Ctrl R. Just need to do this 10 times, right? Okay. Next, now that we have 10 requests ready, we want to send them simultaneously. While one option is to manually click the send button in each tab individually, we aim to send them all in parallel. To do this, click the plus icon next to request number 10, yeah? And then what? And select create tab group, okay? And now, this will allow us to group all the requests together for easier management and execution in parallel. Okay, so we create that. After clicking the create tab group, a dialog box will appear. Hold up, let me just add some minutes to my box because it might die soon at 1 hour. Yeah, sure. Now let's keep going. We were grouping them up, right? Request, yeah, create this. Dialog box will appear asking you to name the group and select the requests to include. For this example, we'll name the group fonts, and then we will, I guess, select all of them, right? And then select all the requests, right? Yeah. Okay, done. Now what? Now we are ready to launch multiple copies of our HTTP post request simultaneously to exploit the race condition vulnerability. Select send group in parallel, last byte. So first we have to create it, right? I guess. It's created. And now what? Okay. To select send group in parallel, last byte sync in the drop down next to the send button. Send group in sequence in parallel. Yeah, last byte sync. Yeah, in the drop down next to the send button, once selected, the send button will change to send group parallel. Yeah. Yeah, it does change. Click this button to send all the duplicated requests in your tab group at the same time, as shown below. Okay, once all the requests have been sent, navigate to the tester account in the browser and check the current balance. You will notice that the tester's balance is negative. Okay, let's send it, right? Sent in parallel. Now you're telling me to navigate to the tester, but it's not here. I'm using this particular browser. So what if I just reload? Oh yeah, I see a negative balance. So you'll notice that the tester's balance is negative because we successfully transferred more funds than were available in the account, exploiting the race condition vulnerability. So by duplicating 10 requests and sending them in parallel, we're instructing the system to make 10 simultaneous requests, each deducting 500 from the tester account and sending it to account 111. In a correct implemented system, the application should have processed the first request, logged the database, and processed the remaining requests individually. However, due to the race condition, the application handles these requests abruptly, resulting in a negative balance in the tester account and an inflated balance in account 111. So verifying through source code. Suppose you're a penetration tester with access to the application source code. Okay. As in a white box testing scenario. In that case, you can identify potential race conditions vulnerabilities through a code review. By analyzing the code, you can pinpoint areas where multiple database operations are performed without proper transaction handling. Below is the Python code that handles the fund transfer. So if user balance is bigger than the amount, execute update user set balance plus where account number is the particular account number, right? So you're passing in the amount and then the target account number. Then can commit, then can execute update user set balance where account number is this, and the session where the account number is this particular session user, right? So in the above code, if user balance is bigger than the amount, the application first updates the recipient's balance with the command update user. Yeah, set balance equal balance plus where account number is the one that they provided, followed by a commit. Then it updates the sender's balance using update user. Yeah, okay. and commits again. Since these updates are committed separately and not part of a single atomic transaction, there's no locking or proper synchronization between these operations. This lack of transaction or locking mechanisms makes the code vulnerable to race conditions, as concurrent requests could interfere with the balance updates. Time for some action. So now that you understand the vulnerability, you can assist glitch in validating it using the account number 101 and password glitched. Attempt to exploit the vulnerability by transferring over 2,000 from his account to the account number 111. So, okay. Can you assist glitch in validating it using the account number? Okay, yeah, sure, we can do that. So we're gonna log out. You're asking me to log in with this particular account number and the password is glitch. Now let's log in, and you're asking me to attempt to exploit the vulnerability, transferring over 2,000 from his account to the account number 111. Over 2,000, did you say? Okay. So let's do that. So what I'm gonna do, what account? This account. 2,000. Okay, so I'm gonna create a couple requests, right? So let's go to this particular post from, no, here, login, transfer. Oh yeah, I have to log in these requests, like transfer, right? So I can get a successful message. And then to the account number, right? So then it's been logged in here. So let's repeat it. Let's close all of them, I guess, right? Close, close, close. Okay. What did I do? Okay, now I want to send this to the repeater, right? So first let's check in. Account number 111. Yeah. Was that the 111? The one that they told us to do? Yeah. So you're making a post request on the amount is that one. Yeah, sure. So redirecting. Okay. So let's send this to the repeater. Now in the repeater, let's just Control R, right, to duplicate. Now let's create a tab group fonts part 2. I'll select all of these requests, and now we have to change this to send group in parallel, and now we're going to be sending more than 2,000, right? So send group in parallel. If we click on this particular thingy, if not, click the link, and if we reload, oh no, not here, in the Chromium browser, there should be a negative balance, but there's not. So did I use this correctly? Maybe I used proxy. There's no time here, right? 44. Session cookie redirecting. So let's reload. Nope. So apparently account number 111, but he shouldn't have a negative balance, right? You can use this glitch validating it using the account number 101 and password glitch. Yeah. Welcome glitch. Attempt to exploit the vulnerability by transferring over 2,000 from his account to the account number 111. Yeah. The account number that I intended to transfer was this one. I sent that in parallel. 302 found. Yeah. Redirecting. You should be redirected automatically to the target. If not, click the link. Let me send group in parallel. Now what? If I update, yeah, no, still. Maybe let's try to duplicate these requests, and then here, funds group. Okay, send all of them. And now if we reload, still 0. Okay, so it looks like something is out here. Let's keep going, right? Fixing the race. The developer did not properly handle concurrent requests in the bank's application, leading to a race condition vulnerability during fund transfer. When multiple requests weren't sent in parallel, each deducting and transferring funds, the application processed them simultaneously without ensuring proper synchronization. This resulted in inconsistent account balances, such as negative balances in the sender's account and excess funds in the recipient's accounts. Here are some of the preventive measures to fix the race. Use atomic transactions. Yeah, the developer should have implemented atomic database transactions to ensure that all steps of a fund transfer, deducting and crediting balances, are performed as a single unit, right? This would ensure that either all steps of the transaction succeeded or none do, preventing partial updates that could lead to an inconsistent state. Then implement mutex locks. By using mutex locks, the developer could have ensured that only one thread accesses the shared resource, such as the account balance at a time. This would prevent multiple requests from interfering with each other during concurrent transactions. So apply rate limits. The developer should have implemented rate limiting on critical functions like funds transfers and withdrawals. This would limit the number of requests processed within a specific time frame, reducing the risk of abuse through rapid repeated requests. After completing the exercise, you will be required to visit this dashboard to get the flag. So what is the flag value after transferring over $2,000 from which account? Well, oh no. Wait up then. I think I've done something horribly wrong. I'm gonna just close worksheet and do this again because I did not get any flag. So, uh, where's worksheet? Yeah, okay. And next, Cyber. Yeah, okay. Let's go to settings, right? And then the Burbs browser. And then allow Burbs browser to run without sandbox. Yes. Now let's close this. Let's go to proxy. No intercept on. I just want to also open the browser, right? Now they told us to access using time. Now that you understand the vulnerability, you can use this glitch in validating it using the account number 101 password glitch. So account number 101 password glitch. Okay, so we do that now. Password attempt to exploit the vulnerability by transferring over 2,000 from his account to the account number 111. Oh, but glitch has 0 bounds right now. Like because of the thing that I did before, right? So I guess so target account number is 111, and then the amount that we want him to transfer is 2,000, right? Transfer. Now insufficient funds. Now we get an error. So how am I gonna go about this? Should I restart the box, maybe? So that we can have a okay. Yeah, okay. So yeah, I'll probably just have to restart the particular box, right? So terminate it. And now terminate, come on. Start the machine again. And why is this not working? Come on. Okay. Oh, oh, what's going on? Yes, exit. So is this gonna load or what? Okay, looks like now it's loading. Did we terminate the day 12? Yeah, but I want to terminate this. Yes, terminate machine. Okay. So now let's start the machine again, right? Yeah, start machine. Okay. So I understand that we have to send more than 2,000, right? Over $2,000 from this particular account. Verifying the fund transfer. So welcome. Yeah, okay, balance 500. So now let's review the fund transfer HTTP request logged in the website feature. There's the proxy tab. Yeah. So I'm just checking out if I did something wrong before. Yeah, account number, amount. Yeah, repeater. Send to repeater. Yeah. And then we change the amount account number from and the amount value from 500 to any other value request as well, shown below. Now navigate to the repeater tab where you will find a pulse request that needs to be triggered multiple times. We can change the account number from 111 and the amount value from 500 to any other value in the requests as well, as shown below. Okay. Place the mouse cursor inside. Okay, so first let's start worksheet. Right, start this, start verb. Now what I want to do is just make the configuration that they told us to do, right? Settings, burst browser and allow burst browser. Yeah, this, let's go to proxy and then open the browser that we're going to be using. And I am guessing that we already have the IP. Do we? Yes, we have a new IP. So let's check this out. Yes. Okay, looks like it's working. So let's go to our Chromium browser. Let's access this, intercepting the request. Yeah, sure. So what we're going to be doing is the same process as before, but this time with this other account that they're telling us to do, right? So by duplicating requests, yeah, verifying through source codes, time for some action, yeah, here. So now that you understand the vulnerability, can you use this glitch in validating and using the account number 101 and password glitch? Okay, free access. Attempt to exploit the vulnerability by transferring over $2,000 from his account to the account number 111. So target account number is this. Then we want to transfer over $2,000, right? So let's transfer 2,000. Let's click on transfer, right? And then we should get a successful message. Yes, we do. So now if we go to HTTP history, we see the post here. Now what we want to do is send this to the repeater, right? Once in the repeater, um, let's follow through here. Now navigate to repeater tab where you will find a post request that needs to be triggered multiple times. Yeah, that's the one. We can change the account number from 111 and the amount value from 500 to any other value in the request as well, as shown below. Okay, place the mouse cursor inside the request inside the repeater tab in worksheet and press Ctrl R to duplicate tabs. So okay, so if I press Ctrl R, let's do the same process as before, all right, 10 times. Now that we have 10 requests ready, we want to send them simultaneously. While one option is to manually click the send button in each tab individually, we aim to send them all in parallel, right? So to do this, click on the plus button and then create tab group, right? And then we're gonna just create multiple fonts. Now I want to select all of them, like the 10 of them, right? And then let's just choose this color, blue. Yeah, okay, we have that. So now we're ready to launch multiple copies of our HTTP post request simultaneously to exploit the race condition vulnerability. Select send group in parallel last byte sync. Here, let's send group in parallel last byte sync. Yeah, And in the drop down next to the send button, once selected, the send button will change to send group parallel, which it does. So click this button to send all the duplicated requests in our tab group at the same time as shown below. Okay, so let's click here. And now, once all the requests have been sent, navigate to the tester account in the browser and check the current balance, right? Let's go to his current balance. You will notice that the tester's balance is negative because we successfully transferred more funds than we were available in that account, exploiting the raise condition vulnerability. So what happens now? Welcome glitch, transfer money, balance 0, but I'm not seeing anything like that. So what is it that I'm doing wrong? Attempt to exploit the vulnerability by transferring over 2,000 from this account to the account number 111, right? Which is the one that we've sent, right? To the account number 111 over 2,000. So what if I tried this and then send in parallel? Like that triggered something? Not really. So let's check out how did he do this, right? Let's check the walkthrough.
Hello and
First versus last.
the second one is there, third, fourth, fifth, sixth, etc. Now, unfortunately, if you transfer your cursor over, it sort of messes up. So if you click this and then we sort of... Okay, now that we understand the last byte sync attack, we can actually use it against our account on the application. So we're going to go back to repeater to this first request that we used to transfer $500 to account number 111. And what we're going to do, we're going to add this to a new group, group 2. And I'm going to hold control and press R 9 times. Okay. And if I then go to send group in parallel, last byte sync, and click send, wait for them all to go through. Now let's refresh the page here. And yes, we now have a balance of negative $4,500. So we started with a balance of $500. We tried to send $500 10 times. It looks like it worked. And that's the last byte sync attack in action. So what we need to do now is use account number 101 with the password glitch, attempt to exploit the vulnerability again by transferring over $2,000 from his account to account number 111. So we'll log out, and we'll log into account 101 with the password glitch.
That's what I did.
And we'll attempt to transfer over $2,000 to account 111. So let's start by doing 1,000. Okay, go to Burp Suite, proxy, scroll down to this. This is the transfer request, 111, 1,000. Right click, send to repeater, and then we will create a new tab group, group 3. Gonna collapse that one. And again, control R 9 times. Then group in parallel. And if we go back and refresh, there we go. We have a balance of negative 9,000, and we have the flag. We can copy this, and then we can complete the room. If you enjoyed this task, there is a race conditions room that...
Oh guys, I'm sorry this is just taking me too long, but I think I understand now. So why did it not work if I was sending the 2,000? Like, I should still be able to, like, get a negative balance, right? So in the first example, how much did he transfer? 1,000, right? Oh, he transferred the half of it. So that's what I was doing wrong. I see you. So now that I have no money, what am I to do? All right, so let's terminate the box again. Yes, terminate the machine. Let's start it again, and then try it again, right? See. Oh, I see. I guess it was not working because once we made the first transaction for the full amount, we didn't have more funds, right? Even though we sent the same transaction multiple times afterwards, in sync and in parallel, none of them were gonna go through just because we have no funds, right? So that's what I was doing wrong. I see. So that's why it's important to actually set up only half, and then you can use that because there is actually, yeah, I understand now. I understand. There's actually that 1,000 that's still pending in balance, and that's what uses the multiple requests. in parallel, in tandem, and then you take advantage of this vulnerability. I see you. I see you now. So what I'm gonna do is, I think I understand better now. So let's go to proxy. Yeah. Yeah, probably just close this, right? Now let's start burp suite again. Okay. Now next, start burp. Yeah. Starting burp. Let's go to settings, burp's browser, allow. Okay, now let's go to proxy. Now let's hope that this has started our new machine. Has it? Just 11 seconds. And then we should have that. So then I guess we can just start opening the browser. And then do we have it? Do we have it, boss? Something is up with this particular room. So I don't know, it's buggy, I think. So let's copy this, right? So let's go to Chromium, copy this, 5000. Now it should take me to this particular thing. Yeah, okay, so now let's go to the particular thingy here. The exercise, right? So I just wanna check the account that they asked me to use. Here, time for some action. Okay. 101 password glitch. 101 password glitch. Then we're sending this to 111, right? So the target account number is 111, and we're gonna be sending 1000 this one, and just to see the request in action, right? So let's transfer. Yeah, successful transaction. Now let's go to verb. Let's go to HTTP history. We see the post here. Now we want to send this to the repeater, right? And then the repeater, basically, what we want to do now is add this, like, let's say 10 times, just like before. Now let's create a group, multiple fonts. We'll set each and every one of them, right? 9, 10, this particular color, create. Now we have to change this to send the group in parallel. And now, if we sent it, that should take advantage of the vulnerability, right? So now, if I go here and then I reload this, yeah, I see this and I also get the flag, right? That was my bad, guys. I'm sorry. It took me too long, but we're learning, right? What is going on here? Chill out. Right, this is the flag. If you enjoyed this task, feel free to check out race conditions room. Okay, might do. Then complete this as well and complete balance shapes and number sort. Look for an entry and open door, right? Yeah, okay. Race conditions. Remember race conditions and how they affect web application security. Okay, I see you. All right. That was everything for today, guys. Thank you for staying around. If you did, I'll see you guys in the next day of Advent of Cyber, right? In the next exercise module, let's say. Let's keep tackling this. I'll see you guys around. Keep learning. Peace.